Welcome to our deep dive into advanced 2D CAD editing. Today, we move beyond the fundamental skills of drawing lines and circles and explore the 4 commands that are the true workhorses of any professional drafter: trim, extend, fillet, and chamfer. These tools are not merely about cleaning up a drawing, they are about transforming a simple sketch into precise, intelligent, and manufacturable geometry. Think of them as the chisels and planes of a digital craftsman. Whether you are an architect defining the clean intersection of 2 walls, a mechanical engineer designing a part that needs to fit perfectly with another, an industrial designer creating ergonomic curves, or an electrical engineer laying out a schematic, mastery of these commands is non-negotiable. They are the bridge between a conceptual layout and a final, professional design ready for production. Throughout this presentation, we will dissect each command, understanding not just what it does, but how and why it does it. We will explore their various options and methodologies, learn how they work in concert with each other, and discuss workflows that maximize both speed and accuracy. By the end, you will have a comprehensive understanding of how to leverage trim, extend, fillet, and chamfer to elevate your 2D drafting skills to a new level of precision and efficiency. Let's begin with the trim command, arguably one of the most frequently used tools in any drafter's arsenal. At its core, trim is a tool of precise deletion. Its function is to remove unwanted segments of geometry that overlap or intersect with other objects. The fundamental concept revolves around cutting edges and the object to trim. First, you define a boundary, the cutting edge, and then you select the portion of the object you wish to remove. This simple action is the key to cleaning up intersections, creating sharp corners, and ensuring your geometry is clean and unambiguous. But the power of trim lies in its versatility. You don't have to select boundaries one by one. Modern CAD systems allow you to use a fence, which is a free-form line that trims anything it crosses, or a crossing window, which selects all objects within and crossing its path to act as potential boundaries. This makes cleaning up complex areas incredibly fast. Furthermore, many programs now have a quick trim mode where all objects in the drawing are treated as potential cutting edges, allowing you to simply click on the segments you want to remove. This is enhanced by dynamic previews, which highlight the segment that will be trimmed before you even click, virtually eliminating errors and guesswork. Mastering these various methods allows you to approach any cleanup task with the most efficient technique, saving valuable time. Following naturally from trim is its counterpart, the extend command. If trim is about taking away, extend is about adding, but with the same level of precision and control. Its purpose is to lengthen an object, such as a line or an arc, until it precisely meets a designated boundary edge. This is indispensable for closing gaps in your geometry, ensuring that lines meet walls, pipes connect to fittings, or circuits are completed without any ambiguity. The workflow is very similar to trim. You select one or more boundary edges, and then you select the objects you wish to extend. The software intelligently projects the path of the object and extends it to the first boundary it encounters. Just like trim, the extend command has evolved to become more efficient. You can use crossing windows to select multiple objects to extend at once, and modern quick modes can automatically detect potential boundaries without requiring you to pre-select them. A particularly powerful technique is the trim-extend cycle. Often you can hold a single key, like the Shift key, to toggle between the trim and extend commands without ever having to switch between them. This creates a seamless and incredibly fast workflow for refining complex geometry, allowing you to trim an overextended line and extend a shortened one in a single fluid operation. Mastering extend is just as crucial as mastering trim for creating watertight, perfectly connected designs. Now, let's turn our attention from sharp corners to smooth transitions with the fillet command. Fillet replaces a sharp intersection with a perfectly tangential arc, creating a rounded corner. The primary input for this command is the radius, which dictates the size of the curve. A small radius creates a tight corner, while a large radius creates a broad sweeping curve. One of the most powerful aspects of the fillet command is its intelligence. It can be used on 2 lines that already intersect, and you have the option to have it automatically trim away the excess line segments to form a clean corner. but it can also join two lines that don't intersect, extending or trimming them as needed to create the arc between them. It can even create a 180-degree arc between two parallel lines. The applications are vast. In mechanical engineering, fillets are critical for reducing stress concentrations in a part. A sharp internal corner is a natural weak point, but a rounded fillet distributes forces more evenly, increasing the part's strength and longevity. In industrial and product design, fillets are essential for ergonomics and aesthetics, creating smooth, touchable surfaces and safe edges that are pleasing to the eye and comfortable to handle. Mastering the fillet command allows you to add both functional strength and aesthetic elegance to your designs. Similar to fillet, the chamfer command modifies corners, but instead of creating a rounded arc, it creates a straight, angled line, also known as a bevel. This is another essential tool for moving a design from a simple representation to a realistic manufacturable object. The chamfer command typically gives you two primary methods for control. The first is the distance method, where you specify how far back from the corner to cut along each of the two lines. For example, a 5x5 chamfer creates a perfect 45-degree angle. The second method is distance angle, where you specify a distance along the first line and then an angle for the bevel. This provides greater flexibility for creating non-symmetrical angled corners. Just like fillet, chamfer can automatically trim the original lines and can be applied to an entire closed polyline, beveling all corners simultaneously. Its main application is in manufacturability. In the real world, perfectly sharp edges are often undesirable. They are fragile, prone to chipping, and can be a safety hazard. Chamfered edges on a hole, for example, can help guide a bolt or a pin, making assembly much easier and faster. It's a subtle detail in a drawing that has a major practical impact on the physical product, ensuring precise fits and safe handling. So far, we've looked at these 4 powerful commands in isolation. However, the mark of a true CAD expert is the ability to integrate them into a seamless and efficient workflow. These tools rarely work alone. They are part of a larger ecosystem within your CAD software. The most critical partnership is with object snaps. Having your snaps for endpoints, midpoints, and intersections active ensures that when you trim, extend, fillet or chamfer, you are connecting to precise geometric points, not just close enough approximations. This is the foundation of accurate drafting. For complex drawings, layer management is key. Before you start a heavy editing session, isolate the layers you need to work on. This declutters your screen, prevents you from accidentally modifying the wrong objects, and makes selecting boundaries and objects significantly easier. And finally, there is speed. The fastest drafters barely touch their mouse for commands. Learn the keyboard shortcuts for trim, extend, fillet, and chamfer. Executing commands with your left hand while using the mouse with your right hand can double your productivity. Combine this with tools like Quick Select, which can highlight all circles or all lines on a specific layer at once, and you have a workflow that is not only precise but incredibly fast, allowing you to refine geometry with unmatched efficiency. With great power comes the potential for errors. While these advanced commands are efficient, using them improperly can create problems that are difficult to fix later. The most important best practice is to follow a logical command sequence. A good method is to work from large to small. First, lay out your rough geometry. Second, use trim and extend to clean up all the major intersections and establish the primary form. Finally, as the last step, use fillet and chamfer to refine the edges. Adding fillets too early can complicate later trims and extends. A common error is over-trimming, where you accidentally remove a segment of a line that you still need. The undo command is your best friend here, but it's better to use dynamic previews and zoom in closely to ensure you're selecting the correct segment. Another pitfall is entering an incorrect radius for a fillet. A value that is too large can cause the fillet to fail or consume more of your geometry than intended. Always double-check your command line inputs. The goal of this entire process is to create what we call clean geometry. This means no overlapping lines, no tiny gaps between endpoints, and no open loops in closed profiles. This isn't just about making the drawing look nice, it's a technical requirement. Clean geometry is essential for subsequent operations like hatching an area, applying accurate dimensions, and successfully extruding the 2D profile into a 3D model.
In conclusion, we have seen that trim, extend, fillet and chamfer are far more than simple editing tools. They are the essential instruments that impart precision, intelligence, and real-world applicability to our 2D designs. They are what allow us to advance from a collection of abstract lines and arcs to a concrete detailed plan that can be built, manufactured, and assembled. Mastering these commands, understanding their nuances, and integrating them into an efficient workflow is a cornerstone of professional CAD operation. Every clean intersection you create with trim and extend, every stress-reducing curve you add with fillet, and every assembly-ready edge you form with chamfer adds value and clarity to your work. Remember that the geometry you create is the foundation for everything that follows. Accurate hatching, correct dimensioning, and successful extrusion into 3D models all depend on the quality and cleanliness of your initial 2D line work. By diligently applying these advanced editing techniques, you ensure that your digital designs are not only visually appealing but are robust, accurate, and truly ready to be transformed from the screen into physical reality. Thank you.